Meet Sarah Chen. She works at North Star Retail, and it's her second week on the job. Her manager just handed her a USB drive containing 10,000 messy customer reviews. She has until Friday to sort them all into positive and negative categories. The traditional way to solve this in programming is to write an explicit instruction. You give the computer an exact rule to follow. For example, you write code that says, if a review contains the word good, label it positive. This logic gate shows what happens when real, messy human language hits a rigid rule. A customer writes, the sizing is not good at all. The program sees the word good, follows its instruction blindly, and a genuinely angry complaint gets stamped positive. To fix this, we have to flip the process entirely. Instead of handing the computer a finished rule, we feed both the data and the desired outputs into an algorithm and let the machine figure out the rules itself. That is machine learning. It thrives on unstructured text too complex for simple if-then statements. Sarah doesn't have to build complex mathematics from scratch to finish her task. She can apply a pre-built machine learning sentiment model to all 10,000 reviews at once. This pipeline shows exactly what that model accomplishes. It ingests thousands of informal, chaotic text documents, determines the context, and translates it into a clean dashboard metric, a 70% positive, 30% negative split across the entire customer base. This matrix shows exactly when to use a tool like this. If you have 50 reviews, you read them manually. But when dealing with massive data scale and high task complexity, you land in the upper right quadrant, machine learning. It is a highly specialized tool. You wouldn't use it to calculate a simple sales tax, but you require it when the logical rules are too intricate to write by hand. Knowing a review is negative is helpful, but Sarah's manager needs to know exactly why. Are they complaining about sizing? Maybe it's poor quality? Or a delayed delivery? Sarah does not have a pre-existing list categorizing these specific issues. Supervised learning teaches the computer using a historical answer key. To uncover unknown topics, unsupervised learning detects patterns on its own, organizing complaints into clusters. Finally, reinforcement learning works by trial and error, adjusting its strategy whenever it receives a positive reward signal. Let's test this. If a bank trains an algorithm to detect credit card fraud using a historical database of confirmed fraud cases, which category of machine learning are they using? They are using supervised learning. Those confirmed past cases serve as the precise answer key the model needs to learn what fraud looks like. To get these mathematical concepts out of the lab and into a real business environment, professionals rely on a standard 5-step workflow. This flowchart outlines the process. Step 1 is framing the problem. Step 2 is data. Step 3 is selecting the model. Step 4 is evaluation against unseen data. Finally, Step 5 is deployment into a live, interactive business report. By Friday morning, Sarah is ready for her meeting. She doesn't hand her manager raw Python code. She delivers translated, localized business insights. She reveals the exact percentage of negative sentiment across all 10,000 reviews. Using the unsupervised clustering tool, she also uncovers a highly specific problem, a massive spike in complaints specifically about a faulty zipper on a new jacket line. Executing a project like Sarah's requires clearing 3 core conceptual hurdles. Let's map them out. First, machine learning generates its own logic by combining inputs and outputs. Second, the 3 categories. Supervised requires an answer key, unsupervised finds patterns, and reinforcement learns via trial and error. Finally, taking a model to production requires 5 steps, from framing to deployment. Mastering machine learning means knowing which of these specific tools to pick and how to validate them for real business impact. Now it's your turn to see it in action. Open the provided notebook and run Sarah's code for yourself.